Hi gents, welcome back to the second lecture. And thanks for the feedback on the first one. It seemed to be positive. People seemed to like the format of it, that we were able to use the video rather than live streaming. Hopefully you found that useful. And since most people said that they did, we'll continue on with that. What we're going to do today is we'll continue on actually with geometry, and specifically similar triangles, just like we had the last time. I'm going to do two questions out for you, just going backwards over the years from the Leaving Cert, and then I'll leave you with one to try. The first one that I saw going backwards, it was 2018 paper 2, and it is let me check here, question 6 if you want to have a look at it, and specifically it was 6b here. This question, again, if you want to, and you should pause the video, have a little go at it, but maybe before you do, if you haven't done it already, you should know that this is, dare I say, offensively simple. It's a lot easier than what it might look to be on the face of it. But anyway, give it a pause, have a shot at it, and see you in a second. So do the sum now, and we'll just have a little look at it. First thing that we see, just read all the questions. We see we have a 90-degree triangle. We've a side 4. We have a side which is 3. So immediately Pythagoras' theorem is coming into play. We have a triangle with side 3, 4. Obviously the hypotenuse is going to be 5 if it is the hypotenuse, and it is. So we know that this thing here, xy, is going to be 5. Obviously, if it was your junior cert or leaving cert, you would just write out the theorem that applies to that. I'm not going to do it here because I know that you know how to do that already. What does it tell us? It tells us that AX, there's a ratio here, AX is to XB is in a ratio of 1:2. Okay, it's in a ratio of 1:2. So that tells us very simply, since we know what AX is actually 4 centimeters, then clearly XB is going to be 8 centimeters. So we know that this thing here is 8 centimeters. Okay, that's all fine, no problem with that. What do we have? Just a few things to look at. We're told that this thing is parallel to that. We're told that this one here is parallel to that one there. What does it essentially mean? It means that we are dealing with similar triangles. Okay, we are dealing with similar triangles. It means that we've got a right angled here. Why are we dealing with that? Whenever you have parallel lines, you have two angles which are called corresponding angles. So I guess you might want to say that. You might just want to say there that will be, I suppose, very official about it. Since the whole thing is so easy, I'd be worried that they might take some marks off if you're not saying everything absolutely perfectly. We can say that XBZ is equal to angle AXY, and I just put in corresponding. And it's the same for that other one that we just did. We can say that Z angle ZXB. You can even just say that it's equal to 90 degrees, I suppose, or you just go and do it formally. YAX, also corresponding angle, same thing, ditto there, and therefore we are dealing with similar triangles. Okay, I would let you fill that one in yourself. You can just say that that side equals that side. Okay, if we are dealing with similar triangles, it's the same plan as yesterday. Draw the two things out. Okay, give them a label. Right angle triangle, that's X, that's Z, that's B. Our other one, which is just a little bit smaller over here on this side, is A, Y, X. Fill in our values. That's 3, that's 4, that's 5, that's 8. I mean, this is ridiculous. Find BZ. Obviously, one side is just twice as big as the other. So, of course, going from 4 to 8, twice as big. So we would just, on the corresponding side, go from 5, obviously, to 10. How would I write it out? Maybe I'd give some sort of a symbol. So we'd say P, maybe do it like this. Always start with the thing you're looking for. P compared to 5, as 8 is compared to 4. Multiply both sides by 5. P is equal to 5 amounts of 8 over 4, 5 amounts of 2. P is 10 centimeters. So just for my examiner, BZ is 10 centimeters. And this time I actually used the right units. So there you go. That was very simple. I doubt you actually had to show nearly half as much as what I've shown in there. It's just very obvious that one side is twice the other, and then you can go from there. Probably worth mentioning that you are dealing with similar triangles. So okay, so worth mentioning here, at least similar triangles. So they might have wanted you to do that. I'm not going to even look up the marking scheme as to what they actually wanted, because it changes year by year. So you're best just covering yourself and just not taking a risk with it, really. So that was 2018 paper 2. If we track back then, and this is 2016. So this is also paper 2, obviously. This one's question 4. So let's have a look at it. We have the diagram shows a semicircle standing on a diameter, and we're told that we have a right angle there. Prove that the triangles ABD and DBC are similar. Obviously you should pause, give it a shot yourself, and here comes the answer. Okay, for this one, to be honest with you, I think it's just easier just to call all the angles different letters or different symbols or whatever it is. So we'll call this guy alpha, call that one beta, call that one gamma, call this guy delta. I suppose we'll call that eta. I don't actually know what zeta is. It's something like that, I think. Okay, so if we just call it like this, it'll be a little bit easier just to write it out and why. Okay, what do we start with? Start with something very trivial. Say alpha plus beta plus. It is given to us that zeta is 90 degrees, so we'll just say 90 degrees is equal to 180. Obviously true, since those are 3 angles in a triangle. Simple enough, and therefore follows with alpha plus beta also has to be 90 by taking 90 away from both sides. Okay, the real trick to this one is knowing about beta plus gamma. Okay, beta plus gamma, as it turns out, also have to be 90 degrees, but it is up to you to spot why that is. So this is really a junior cert proof. I'll just draw this in. You wouldn't have to draw this in, but it's just to remind you. If you have an arc, okay, this is your arc. That's that thing down there at the bottom of it. If you've got an arc, and if you join the arc to the center, and if you join the arc anywhere on the circumference, what you'll find is that the angle that you have in here will be twice the angle that you have up at the circumference. Okay, so that's called angle at the center is twice the angle at the circumference. And a run on from that is, if you have a really big arc, to be exactly half the circle. Okay, so that's it there. So now when I join it to the center, what I'm really doing is I'm creating a diameter and I'm creating half a circle. So we've got a semicircle now. And our angle is, of course, 180. It's a straight angle. And now if you take that arc and if you join it all the way up here, you of course get half it, which is to say a right angle. And that's true for anywhere that it is on the circumference. So if we make it look a little bit more like the one that's up there, despite my drawing, we know that that's a right angle up there. So very importantly, we'll just get rid of everything that I have there. Very importantly, we can say, and it's the major part to actually figuring this out, to proving it properly, we can say that beta plus gamma is equal to 90 degrees, and you actually just have to say angle in semicircle. That just tells them you know the proof, you know what you're talking about, and go from there. Well, that obviously means that alpha plus beta is 90 and beta plus gamma is 90, therefore they're both equal to each other, both 90. And if we take beta from both sides, alpha is gamma. Okay, so that pretty much gets us there. I suppose it's worth saying maybe also that epsilon has to equal zeta. The reason is that they're both 90, and if you really wanted to shoot it, you can just say it's also a straight angle as well. Okay, so what do we have now? We have one set of reasons here, okay, for the reasons above. You've got a second statement here and a reason given, and of course what we said yesterday was the third thing that we can say is that beta is equal to delta, and the reason is that they are the remaining angles in a triangle where the other two angles are the same. So there you go, that would be that. We've got our three statements. We can say therefore triangle ABD is similar to triangle DBC. And don't forget little QED. Okay, there you go. That's the sort of standard, I guess, that they're really setting. It's generally just one little trick, and you just have to keep your eyes open for it and go from there. What do we have here? One little bit then, just to finish it off. Okay, if AB is that and that is that, right, in terms of that. Okay, what I would suggest is we're just after getting that they are similar triangles. Same approach as always is draw out both things. Okay, draw out both. You might need to manipulate one of them here, I'm sure we will. That's A, that's D, that's B. Okay, we know that we have a right angle. I'm just going to call this guy beta up here and that guy alpha as we did in the other one. Now, what you want to do is you want to orientate this other triangle in the same way. So you just want to make sure, since it's alpha and gamma that are the same, how are we going to have it lined up so that they look the same? You'll have to take the triangle DBC and you're basically going to rotate it, which direction is that? Anti-clockwise 90 degrees. Okay, so you're going to let it fall over to the left. So if you had a picture editor or something like that, if you took a photo sideways accidentally, you would be saying rotate left. So if we do that, it should look like the same, albeit just a bit smaller. So that's what we have here. That's our gamma down here. We still have a right angle up here, and we've got delta up there. So let's just make sure the right angle, it was B. Up at delta, it was C, and down here it was D. Okay, really important that the orientation is correct and that you label it. All good ideas there. We'll now fill in our values. We know that A to B is X. So that's that one there. We know that B to C is 1. And we know that BD is Y. And it might look like, oh, we don't have enough information here because we've got X compared to Y and then nothing compared to 1. But of course, BD actually comes in there twice. Okay, BD is in the left-hand triangle as well as the right-hand triangle. So there we go. We have BD is Y. Okay, and what's it ask for? Right, Y in terms of X. So your final answer should be Y equals, and there should only be numbers and X's on the other side. There shouldn't be a Y or any other variable, not that there is another variable on the other side. Always start with the thing that you want. So you can say Y compared to, now it's up to you which way you want to go, because of course the Y is in both things. So I'll just go from big to small here. I'll say Y compared to 1, big triangle compared to small triangle, is X compared to Y. Okay, again from big to small. What you want to do here is just get Y equals, so Y over 1 is just Y. Multiply both sides by Y. Y squared is equal to X. And remember, we are trying to get Y equals and just have X's. In this case, we want to square root both sides. Be very careful. If it was a real algebra question, the answer, of course, would be Y is equal to plus or minus the square root of X. In this case, of course, it can't be a negative. So you can just go straight to saying Y is equal to root X. And that's the answer for it. So what I would say to you is, it's relatively straightforward. I know these are leaving cert questions. They could absolutely appear in the junior cert, and not be out of place. There is what I would say to you. So as far as I'm concerned, I'm happy enough that we've done similar triangles. You should be able to do one now yourself. I'll just find one for you here. I think I had one laid up for you. Yep. If you want to give a try to one now, this funny enough is a fair degree harder than those two ones that you've had there. So this will test whether you know it or not. Give it a shot yourself. I'll throw up the solution to it tomorrow. It's 2014. It's paper 2, and actually the leaving cert was a slightly different format. That back in 2014, you'll see that when you get to question 6, it was split up into two things. You could either do 6A or 6B. That's not the case anymore. But this one is 6B on its own. So if you want to do 6B, do all of it, and that will tell you whether you know your similar triangles or not. Right, I'll catch you tomorrow for the next video. All the best. Cheerio.